everybody. My name is Kiran. I am working as an assistant professor in the department of EEE Anits. I welcome you all to my series of lectures on the course DC machines and transformers. So I have divided my entire lectures on this course into 4 modules. In my first module, I will discuss the various concepts under the cloud DC generator. In my second module, I will be discussing various concepts under the cloud DC motor. The third module, I'm going to discuss various testing methods of DC machines. And in the last fourth module, I am going to discuss various concepts under three-phase as well as single-phase transformers. So first we'll see the module 1, that is DC generators. So in today's lecture, we are going to discuss regarding the introduction of the DC generator, as well as we are going to see what is the construction details of DC generator. So we all know that all electrical machines, particularly rotating machines, are basically electromechanical energy conversion devices. Either they convert electrical energy to mechanical energy or mechanical energy to electrical energy. If the machine converts mechanical energy to electrical energy, we call them as generators. And if the machine converts electrical energy to mechanical energy, we call them as motors. And the basic principle on which my generator works is Faraday's law of electromagnetic induction. We all know that the first law of Faraday's law is nothing but whenever a coil or conductor cuts the magnetic field, an EMF is induced in that conductor or coil. And we can also define that in the other way, that whenever the flux linking a coil or conductor changes, an EMF is induced in it. And the second law of the Faraday's law states that the magnitude of induced EMF in a conductor or coil is equal to rate of change of flux linkages. So therefore, the three main essential requirements for a generating action are: the first one is uniform magnetic field. The second one, we should have a conductor or a group of conductors. And the third requirement is there should be relative motion between the conductor and the magnetic field. So these are the three basic essential requirements for generating action. So let us now discuss in detail the construction details of DC generator. So this is my overview of the construction of a practical DC generator. This is the cut section view of my DC machine. So I can mainly categorize the various parts that exist in DC generator into 6 main parts. First one, yoke; second, poles; third is field winding; fourth is armature; fifth one is commutator; and sixth one is brushes. So let us see in detail the function of each part and of what material each part is made up of. So these are some of the pictures or diagrams of practical yoke. So as you can see, it is nothing but the outermost cover of your DC machine. Okay, so the main function of the yoke is, the first function is it serves as an outermost cover of DC machine, protecting it from harmful gases, dust and moisture. My second function of yoke is it provides the required mechanical support required for the poles. If I go back to my construction diagram, you can see these poles that are present here. So the yoke will give the required mechanical support required for these poles. That is my second function of yoke. And the last, third function is it carries the magnetic flux produced by the poles. And the material that the yoke is made up of is cast iron or cast steel. The reason behind this is every part of my DC generator should have the capability to allow magnetic flux to pass through them. So in other words, the permeability should be very high. So since permeability should be very high, the material is made up of cast iron or cast steel. The second as well as the third part that we want to discuss is nothing but poles and field winding. Okay, so these are some of the practical diagrams or pictures of yoke and field winding. They are, as you know, they both are together because the field winding will be wound around the pole, that you all know. Okay, so on the right side you can see the pole is mainly consisting of two parts, pole shoe and pole core. The main function of pole core is it carries the field winding which is necessary to produce flux, and pole shoe has two main functions. The pole shoe spreads out the flux in the air gap, and the second function, it reduces the reluctance of the magnetic path. And the material it is used is cast iron or cast steel. Okay, so coming to field winding, the field winding main objective or the main function is to carry the current due to which it can behave as an electromagnet. And the second function, it helps in producing the required flux. Since we need to wound this field winding around the pole, it should have the good property to bend easily. And since it needs to carry the current, it should also be a good conductor of electricity. Hence, the material used for field winding is copper. The next fourth part is the armature. The armature can be divided into two parts, that is armature core and armature winding. These are some of the diagrams of the armature. So these are the windings, as you can see from the diagram. These are the windings, and the cylindrical part that you are seeing is armature core. So first we'll see armature core. So these are some more diagrams of armature winding and armature core. The cylindrical part is nothing but the armature core. The first function is it holds the armature core holds the armature conductors. In the right side diagram you can see the armature core has some slots provided on the entire periphery. So in these slots that are present in the armature core, the armature conductors are placed. The second function of armature core is to provide low reluctance path to magnetic flux. Armature winding is nothing but interconnection of armature conductors that are placed in the slots that are provided in the armature core. So the only function of armature winding is the generation of EMF in DC generators takes place in the armature winding. And the material used for armature core is cast iron or cast steel. Yeah, coming to the types of armature winding, we have two types of armature winding. One is lap winding and second one is wave winding. In lap winding, the number of parallel paths are equal to number of poles. So suppose we have 4-pole machine, so the number of parallel paths will be 4. Okay. In second case, wave winding, the number of parallel paths is equal to 2. So that is irrespective of the number of poles, the number of parallel paths will always be 2. Okay, so that is the main difference between lap winding and wave winding. Okay, the last two parts of the DC generator are the commutator and brush assembly. So both also are together. So you can see from the diagrams how my commutator and brush assembly are put together. The main function of the commutator is to convert alternating EMF to unidirectional EMF, because we know that the output of my DC generator is AC. That you will come to know in the coming topic, that the output of either AC or DC generator is always alternating in nature, but in DC generator we need the output to be DC. So that is why we use a commutator to convert that alternating EMF to unidirectional EMF. And the second function of commutator, it collects the current from the armature conductors. Okay, since it needs to carry current, so the commutator segment and the armature both are interrelated. Okay, both are connected together. So, and the brush assembly also is also connected to armature, commutator. So here we use the material used is copper, since it needs to collect current from armature conductors. It should be a good conductor of electricity, so therefore the material is used is copper. And lastly, it is the brush assembly. You can see clearly from the diagram that both commutator and brush assembly are together, but commutator is rotating in nature, whereas brush will never rotate. It is always stationary. Okay, so from the right side diagram you can see those black brushes that are kept in holdings. Okay, so those are always stationary. Okay, they will never move. So the main function of brushes is to collect the only function of brush is to collect the current from the commutator and make it available to my external circuit. Here the reason why carbon is used for brushes is to avoid wear and tear of the commutator. So this concludes my today's lecture on the construction of DC generator. So we are going to meet in my next lecture with some other topic. Until then, goodbye. Thank you.